Up until this point, our salt formulas have only included what are known as monoatomic ions. Mono is a prefix that means one, atomic means atom, and ion means charged. So for instance, we worked with oxide, O2-, or nitride, 3-, or chloride, 1-. These are singular atoms as ions, monoatomic ions. However, there are many salts that are made from what are known as polyatomic ions. Poly meaning many, atomic meaning atoms, and ion meaning charged. This video is going to show you how to find the charge of polyatomic ions and write them into salt formulas. I'm also going to talk about the middle section of the periodic table that I did not speak about last time. So recall that on the periodic table, the charge at the top of the column tells you the charge of the ion for everything down in the column. However, there is an entire middle section here that has no numbers above it, but these metals can form ions. Everything in here is a metal, but they are special metals. These metals are known as transition metals, and these transition metals can have multiple charges. A really common one that we will use in this class is iron. Iron can be 2+ or 3+. In the older naming convention, this would be known as ferrous, and Fe3+ would be known as ferric. This ending changing is something you can see in a lot of transition metals, and it depends upon what the maximum charge is and the lowest charge can be. I'm not going to talk very much about that, but you should know ferric as 3+ and ferrous as 2+. For the most part, if you're not told, you can find the charge of transition metals on the back of your periodic table in the solubility table. All of these metals here on the side are the charges that I will generally use for this class, unless otherwise denoted on your assignment. For this class, we will use copper 2+, and lead 2+, silver +1, zinc 2+. I have both irons on here because we do use both forms of iron quite frequently, as well as nickel 2+. If there are other metals, I will either give you the charge, or you can find out the charge of a metal based on the way that it is bonded to a negative ion. The second thing we need to talk about are polyatomic ions. Polyatomic ions are not singular atoms, they are multiple atoms. One example of this is sulfate, SO4. This sulfate ion looks like this. You can see from this molecule here that our polyatomic ion is actually made up of one sulfur atom bound to 4 oxygen atoms, and these are bound in a different way that we will talk about later. Sulfate has an overall 2- charge. It gets treated as one unit. Again, on the back of your periodic table, you can find the names and the charges and the formulas for all of the polyatomic ions that you will use in this class. You will treat each one as a singular unit when writing your salt formulas. Let's do an example. Calcium hydroxide. First thing that we do is the same that you would do with any salt, is write down the charges. Calcium is +2. Hydroxide, this is our new one. If we look on the back of our periodic table here, we'll see hydroxide has a formula of OH and it has a charge of 1-. I'll first start by writing these in a 1-to-1 ratio, but what I'm hoping you see is that this does not form something neutral, this forms something with a +1 charge. In order to fully make this neutral, we have to add another negative ion, which would be our hydroxide. And this is the formula of calcium hydroxide. Now the tricky part here comes in writing the salt formula. The first part is the same, you write the calcium, but now I need to communicate that I have 2 of this entire ion. There are several ways that I've seen this written, and only one way is correct. I'm going to write them all and you can think about what is the correct way. Think to yourself, what would be the correct way to write this salt formula? If you chose option number 2, you would be correct. The parentheses are always used around polyatomic ions. When you have multiple polyatomic ions, you surround the polyatomic ion in a parentheses and then you put a 2. The first one is communicating that I've got water, 1 oxygen and 2 hydrogens. That is because the subscript only applies to the thing that comes directly before it. When we use parentheses, we are communicating that we have 2 of the entire ion. You might have chosen number 3 because this does communicate that yes, there are 2 oxygens and yes, there are 2 hydrogens. The issue is that what it is communicating is that this is one molecule together instead of 2 separate molecules like I have in the salt formula. That would look like hydrogen peroxide like this. And you can see that this polyatomic ion is not the same as OH, just like water is not the same as OH. So the convention is when you have a polyatomic ion and there is multiple of them, then you use parentheses. You should be able to do the rest of the work now.